Okay, so we are in week 5 functions, correct?
Yes.
Good. So, let me tell you about functions. So let's say you have some lines of code. Let's do some stars that are repeating. So let's say you have this here, right? And then down the line you decide to use the same 4 lines of code, and it doesn't have to be 4 lines of code, it could be 4,000 lines of code. Okay? So far as you know, if I run this thing, it'll just show you that. Okay? So instead of rewriting the same lines of code, what I'm going to do is I'm going to create a function. I'm going to call it df stars. That's my function. So the function name is stars. Okay? Functions always have parentheses after them, which should tell you that print is actually a function. Okay? So I'm going to go in there, I'm going to tab all this stuff inside. Okay? And I'm going to say that this here is the beginning of function body, and this is the end of the function body. Okay? And now wherever I had those stars, I'm just going to call my function. This is the function call, stars, right? And then, so that was the first 4 stars. And wherever these other 4 stars were, I'm just going to erase this. And I'm going to say stars again, which is, again, your function call. And I'm going to run this thing. And same thing. All right? So that's a basic. That's your function definition, the function call. That's the basics of a function. So let me have a look at the class page. Basic function. I showed you that stuff. All right. Okay. So that's that. Function parameters and arguments. All right. So this is a basic function that does not accept any values. And now what I'm going to do is function with parameters. Okay, so let's say I'm going to have a function called df add, right? And it's going to take 2 values, num1 and num2. Okay, in other languages you have to tell it what these data types or these values are going to be, so you can tell it like, this one is an int and the other one is like a float. But Python automatically figures out what the data is as you send the information into the function, so you don't have to do that. So it could be it doesn't even have to be just numbers. But let's stay as numbers, and I'm going to say, all right, sum, or let's just call it total, is equal to num1 plus num2, and I'm going to say print total equals, or let's just do it this way. I'm going to say num1 plus num2 equals, and I'm going to go throw total there. Okay? And now I'm going to call the function, so the parameters are in here, right? I'm going to put it right here on top. Okay, so function name is add, and function parameters are num1 and num2. Okay, so these two variables, they have a special name. This one and this one, right? These are the parameters. Okay, and I'm going to go and call the function. This is calling a function that accepts values, right? So what we're going to do is, I'm just going to say, all right, add 1 and 2. All right, let's do 10 and 20, a little bigger. Okay, and so this and this also have their own special name. These are the arguments. Okay, and this is important stuff because I'll show you in a second how some of these error messages that you probably have gotten already can be explained if you understand functions and what an argument and parameter is. Okay, so these are the arguments. Arguments are the values that we pass into the function. Okay? And if I run this thing, F5, right, it shows you 10 plus 20, right? I can go in there and I can change this to something else. So I'm going to go in there, paste this to 1 and 2. Right? Now these are the arguments. Right? So it basically works with different numbers. You can send in different numbers into the function. And these are the arguments. The arguments don't have to be just values. They could be variables. So let's say I'm going to call this argument 1 is equal to 100, argument 2 is equal to 200, and I'm going to say add arg1, arg2. And by the way, notice how it kind of tells me, it knows, because I have already defined the function add, that these are the two parameters that are going to be expecting the values. Okay, so arg2, and if I run this again, and it's going to do the math for those two numbers. Okay, so that's function, arguments, parameters. Let's call this argument. Argument. That's 2. Okay, so function with parameters, calling a function that accepts values or arguments. All right, any questions on any of this stuff? All right, still pretty basic. Okay, now next thing is, and this is in your functions, parameters, and arguments, functions calling functions. I guess I can show you that. So let's say in a lot of programs, in a lot of programming languages like Java, like C++, like C, there is a function where the whole thing starts, okay, and it's called the main. Right, and in C++ is just int main. In Java, it's public, static, void, main, string, square brackets, args. I know, right? That's why some people have an aversion towards Java when they first start, but it's actually a really nice language. Okay, doing more complicated things with objects and stuff like that. If I do data structures, I would much rather do data structures with Java than Python. For the record. Okay, so anyway, Python doesn't have a main, but we can make a main. So this is functions calling other functions. Oh, and by the way, before I do any of this stuff, let me remind you about, let's say, age is equal to int input, and I say, let's say, age is equal to -99, and I say something like, age is age, enter another. Okay? And when I run this thing, have a look at the error that it's going to give you. So it tells you input expected at most 1 arguments, got 3. Okay? So now that you know what an argument is, right? So input is expecting one thing, you're giving it 1, 2, 3 different arguments. Right? So if you know what an argument is, it helps you debug your programs, but you should know the terminology. Okay? So this is the little error that I got here, is type error. All right, just to remind you. All right, oops. Okay, so this is that, and I'm going to comment out this stuff so that you know. Okay. Now, functions calling other functions. So I'm going to simulate, like, let's say this is how C++ would be working. You would have something like a main, right? This is where the program would start. And instead of me calling my functions here, I will be calling them all inside of the main. But I'll still leave them there. I'll just show you that I can call it from here too. So I'll go add 1000, 2000, right? And I'm calling it from inside my main. And if I run this program, see what it shows. It didn't show me that last one. Let's see if you're paying attention. Why is that? Why didn't this show?
You didn't call it
I didn't call what?
the main.
All right, awesome. right? I need to call the main in order for it to call the other thing. Okay, so I'm going to go in there, call the main, and there you go. Now it works. Okay, keep in mind that you can only call a function after you have defined it. If I try to call this thing here, it doesn't know what main is, right? So the program works top to bottom. You're trying to call the main, but you're defining the main after you're calling it. So that's why it doesn't know what main is. Okay? So I'll move that here. All right. So this is functions calling other functions. And you can also have a function calling itself, but let's get into that later. Okay? So now the next thing I'm going to show you is a function that returns a value. So let's see, functions calling other functions. Yeah, the main business, I showed you that. Okay, now function return. All right, so let's say I have another function which is going to show me, I don't know, if a number is positive. Okay, so function that returns a value. Okay, so let's say what I want to do is I want a function that returns true if a number is positive and returns false if the number is negative. Okay, so I'm going to go in there, I'm going to say df is positive, right? And I'm going to send in a number into it, right? That's my parameter, in case you forgot. All right, this here is the parameter. Okay, and then the next thing is I'm going to check to see if my number is less than 0. I'm going to return true, and then else I'm going to, let's just do elif. I'll just do return false right here. Return false. Okay, so let's have a look at how this thing works. Actually, I'll just add another one. So is positive, yeah, opposite. All right, if it's bigger than 0, return true, and then if num is less than 0, you return false. Okay. 0 doesn't count. It's neither positive or negative.
But it's not going to know what to do if you
It won't know anything. It won't return anything. Well, we'll look at that in a second, right? So if they enter a 0, what happens? Okay, and that's a good point because we don't have no default return case. So basically, if you have an if and an elif or something like that, if you have a fancier compiler like PyCharm, not idle, PyCharm will highlight things. It will tell you, oh, hold on, there might be a case where this function doesn't return anything. And that's what Marissa just pointed out. But we'll look at it. Okay, so let's see how this works. So I'm going to say, so first of all, how do I call a function that returns a value? If I do this, is pos 10, right? And if I just run this thing, nothing happens. Why is that?
You didn't tell it to show.
So what's wrong?
You didn't tell it to show.
I didn't tell it to show. Show what?
Show the return.
Okay, so it is. I'm calling the function. It's returning a value, but I'm not showing it, right? So there's two ways you can call a function that returns a value, right? So two ways to call a function. Well, a couple ways, I guess. There's more than two. Two ways to call a function. Let's go. Ways to call a function that returns a value. Okay, so one way is you just call it from inside of a print, right? And that'll do the magic. Okay, if I run this thing, it's positive, it's true, right? So let me do this. I'm going to say the number 10 is positive. And I'm just calling my function inside of the print. Okay, that's one way. Another way to do this is I can just say something like return, another way to call it, right? Another way to call it is you just store the value that it's returning somewhere. So let's say returned value is equal to is pos 10, right? So I'm going to call is pos, we're going to go in there, it's going to return either true or false, and it's going to store that value into this return value variable, and then I'm just going to show you that variable. Okay, I'm going to copy this, put it in there, okay, run it again, and you should see the same thing twice. There you go. Bless you. Twice. Okay, 3 times. So this is how you call a function, right? There's more ways to call this, right? I can do something like this. Another way to call it is you could call it from inside of an if. So I can say, all right, if is pos num, right, is equal to true, I can give you the message then, right? And that's a more real world, well, another real world application of how you would be using a function, right? From inside of an if. So you basically have a whole bunch of things that are happening inside of the function. Once you write the function and you know it works, you don't even need to you don't need to concern yourself with the details of that function that much, right? It's basically the functions become the interface of your program. And what's the interface? It's like the way you interact with the thing. Okay? You don't have to have a very fancy interface to get the program working, or you don't need to make things complicated for yourself. Right? When I press the buttons on the remote control, I don't concern myself with the details of how the projector works or the TV works, right? I know if I press the power button, it turns off. And that's the same way. You're pressing buttons by calling your functions. You don't need to concern yourself with, well, I need to take the TV apart and look at the wires and, hardwire things to get the volume up. No. Somebody's done that already, programmed the thing for me. I just press the button and now it's done. Okay? So that's called encapsulation, hiding the details. All right, so I'm going to run this one more time. And, these functions could be complicated things. Whoops, num is not defined. Yeah, it's not num. Oh, that's a good point now. All right, so notice that when I'm calling this thing here, name num is not defined. That's going to bring me to the next thing that I want to tell you about, and that is scope of variables. Okay, so if I do this, right, this doesn't work. Does not work because num is not defined. But it is defined. I define it right here. Doesn't matter. Okay, why? Because parameters, okay, the scope of the parameter variable num is only the function is pos. Right? So what's a scope? Is pos. Right? So what's a scope? Scope refers to where the variable can be used or seen. Right? So nothing outside of the num of the isPos function has any idea about this variable num. Right? So if I try to call it like this here, right, it's great, but what's num? Nothing. It doesn't know what num is. Okay? So let's say I have in my main, right, I'm going to go in there. Alright, so I'm just going to copy this thing here. Alright, while we're on the topic of scope. So this didn't work, and you're getting this error. Okay? And why are you getting this error? Num belongs to num is local to the function is pos, right? So whenever you define a variable inside of a function, it belongs to that function, it's local to that function, the scope of that variable is only that function, and you can't use it outside of the function, otherwise you get an error. Okay, so what I'm going to do is I'm going to copy this thing here, paste it right there, and instead of num, I'm just going to go give it some value like 99. Okay, and now when I run this thing, oops, if I run this thing, then it should work. Right? So this thing is equal to true, so I'm showing this message. Okay? There's a way for you to simplify this. And again, if you're using PyCharm, you're going to see that just a lot of times it will highlight things. It will tell you, you can simplify this. Yeah, you can. So instead of doing it this way, I can do it just like this. Right? Because the thing returns either true or false, and the if works with a true or false. I don't need to say equals true. Right? It's either going to be true or false. And that's it. Okay? So if I run this thing in again, I run it. And, oops, num is not defined. What did I mess up again? Oh yeah, 99. Run it one more time. There you go. Now it works again. Any questions? Yeah.
How do I, instead of returning like a Boolean answer, how can I return a variable, a local variable?
We'll do that right now. Okay. So how do you return a local variable is the question. All right, so let's do this. So returning a local variable, right? You just say, all right, so I'm going to have df add 2, right? And we're going to have a, b, c, right? What this thing is going to return is going to return total. Total is going to be equal to a plus b plus c, right? So all of these are local variables, right? So the variables a, b, c, and total are all local to the function add 2, right? Okay, so what I'm going to do is I'm going to returning a local variable. I'm going to return total. I'm going to say return total, and that's it. So that's how you return a local variable. So let's go in there and say, all right, this is going to be the sum is equal to add 10, 20, oops, add 2. Notice how it's guiding me again. When I set add, right, it automatically tells me this. And by the way, notice if you do print, look what it tells you. These are the default parameters that are expected by the print function, right? Notice that there's a bunch of values in there that you can separate from each other by commas. And then there's an SEP parameter, which is equal to blank. So that tells it basically, if you don't overwrite this thing here, if I go in there and I say, all right, 1, 2, right? Let's do 3, right? And I just leave it like that, and I run this thing. Oops, let me fix that part. Right? If I run the print this way, you know how it works, right? 1, 2, 3 separated by space. Okay? But then what I'm going to do is I'm going to copy this thing. I'm going to do a print. And now I'm going to override the default, what SEP is equal to, right? So I'm going to do a comma SEP equals quote, comma, quote. And then I'm going to put all these other ones in front of it. All right? Run it. And now it separates them by I told it to separate them by comma. Right? That's the separator. The default separator is a space, which is why it looks like this, right? And by the way, that's why it inserts automatically a new line at the end of each print. I can override that too. So print, right? Notice separator, and so the default end, the way you end these print lines is using a \n, which is just a new line. So that's how we overrode it before. I'm going to grab this thing here. Copy this, paste it. I'm going to say and is now equal to, I don't know, this. Right? So instead of a new line, we're going to override it to this. And I'm going to do print 3. All right, that's 3, 4, 5. Okay, have a look at how that looks. If I run it. And there you go. Okay, So if you know your parameters, if you understand how functions are being called, if you know the basic terminology, makes your life much easier. Okay, so back to returning a value. I'm going to go in there, sum, and by the way, sum, notice how it's purplish. It's because it's one of those reserved words, just like print, but we're not going to use it for anything, so I'm going to override it. So I'm going to override the function sum to something else, and that's going to be add 2, parentheses, now it wants 3 values, 10, 20, 30, right? And I'm going to show you print the sum of 10 plus 20 plus 30 is sum. Okay, and hopefully my function works. And there it is. Okay, so this is how you're returning a local variable. Yeah?
How can does it make total a global variable at that point though?
No.
When it returns it?
Total is a local variable, and let me show you. So, all right, total is still a local variable. I'm returning it, so let's try total. All right, you're gonna get that same. Doesn't know what it is. Name total is not defined.
At the end of that, could you do total equals sum?
I can do that. If I do total is equal to sum, I am now defining a different variable total. So this total here is different from this one. Okay?
So to reference it though, I have to run the function. Like I'm referencing the function and the arguments together in order to get that total.
Yeah. Yeah.
So we quick away.
Okay. You could also return lists. You don't have to return a single thing. If you're sending a list into a function. Oh, and by the way, notice, let's do this. So changing the parameters does not change the argument. And what I mean by that, argument is equal to 0, right? df no change parameter, right? And I'm going to say, when I'm going to call the function, I'm going to go in there, I'm going to say, okay, no change argument, right? I'm sending the value of the argument, which is 0, into the function. As soon as I make this call, right? As soon as I make this call, parameter equals argument, okay? But if I go in there and say something like parameter is equal to 100, okay? When I go in the end and I do print argument, what is this going to show me? Is this going to show me 0 or 100? Zero? Okay, I kind of gave it away with the name of the function. Okay, so if I go in there, let me copy this. Right, argument is equal to this. Oops, total, where's that total? Oh, yeah, total is not defined, right? This one is an error. Error because total is defined and visible only inside the function, what was the function name? Add 2. Add 2. Okay? So, going back, run it again. Right? So it's 0. And, yeah, so changing the parameter. Changing parameter here does not change the value of argument. Okay? So that pretty much illustrates what's up with the scope of these variables. And by the way, so this is, these are local variables, right? You know what local variables, so the parameters are local variables, this is a local variable. If I defined a variable here, something like pi is equal to 3.14, okay? Pi is defined before and outside of all the other functions, right? So pi is a global variable. Okay, and what's a global variable? Global variable can be seen and changed by all functions. So I can change it inside of the functions, I can change it outside of the functions. If I go in there and I say pi is equal to 0 here, and I go and say pi is equal to 333 here, it's fine, right? It's not going to give me an error. So let's just run it. No errors, right? And if I go in there and I do print pi all the way at the end, pi equals pi, what value am I going to get for pi? Is it going to be 3.14? Is it going to be 0? Is it going to be 333? You think it's going to be 0? Keep in mind that I'm calling, so it starts at this 314, then it goes to 0, then I'm calling the functions, this function a couple of times, so it's going to make it 333. So let's have a look. When it's all the way at the end, 0. Okay? So this is, it's a little tricky thing. So when I do pi 333, what it's actually doing is it's creates a local variable pi. Okay, there's ways for you, there's a syntax in the language itself that you can tell it, oh, this is a global we're working with the global variable pi. But the reason why it's doing that by default, so by default Python does not change the global variable pi, but makes a local one, okay, a different variable. Even though it's the same name, this is a different variable that refers to some different place in memory. Why do you think it's doing that by default? Why would I not want to be able to change this thing from inside the functions?
Because we might want to use the global pi for something else, a different function.
Yeah, so basically the idea is this. Let's say you have some monster project and you're on a team with a bunch of programmers and you're working on one of the functions, somebody else is working on another function. Actually, global variables are bad practice. They're not a good thing to do, right? Why? Because if I was able to change my variable easily, I can mess up your work, right? Because we're all using this global variable for something, but I went and I changed it to 333. Now the whole program stops working. Okay, so that avoid using global variables in Python is kind of nice that it does this for you, right? It does not let you change the global variable. Even though you could, there's syntax in the language that lets you do it. So avoid global variables. That's the bottom line. What else? Let's have a look at how it does things with lists, just as a last little example. Okay, so let's say sending a list as a parameter, or having a list. A list is a parameter. So let's do this. I'm going to say, all right, df another a list, and then let's say my list originally, I'm going to call the function like a list. Oops, not a list. I'm going to make a b list here is equal to 10, 20, or let's just do 1, 2, 3. 1, 2, 3. Okay. What I'm going to do is I'm going to call my function another. I'm going to send the b list over, and then what I'm going to do is I'm going to say, let's try this. So I'm going to say a list 0, right? That's the first element. So by the way, lists have indexes, right? Indexes 0, 1, 2. Okay. So what I'm saying here is I'm going to change this one to something else. Right? So I'm going to make this a 0. And okay, that one is going to be a 0, 2. And the last one this is also going to be a 0. So I'm going in there and I'm zeroing out this list. Okay? That's all I'm doing in this function. And then my question is, what do you think it's going to do when I do blist equals blist? Right? Is it going to show me the 1, 2, 3? Or is it going to show me something else? Your guess is as good as mine. Let's have a look. It changes it. Okay, so lists do get changed. Okay, so normally, again, remember, changing the parameter does not change the argument unless it is a list. Okay, if you have a list, you get to change it. Okay? So that's that. And by the way, you can also return. You can go in there and say return a list. Right? If you didn't know that, right? You say, well, hold on, I don't know if it's going to change it. You can just say, well, blist is equal to this. So even if you didn't know that it would change it, right? You're going to go in there, you're going to send the 1, 2, 3 list, you're going to make it equal to 0, 0, 0. You're going to return the 0, 0, 0 list. This is going to equal to whatever this thing is returning, and that's it. Okay? Another thing is if you have a return, let's say I have something after the return, like print hi. I don't know if it's going to give me an error, but let's have a look. So if I run this thing, there's no hi, right? So what's the problem? The problem is the function exits here. The function exits at the return, and nothing after it will happen. All right, so I can have a million lines of code after my return. The function's out. As soon as I get to the return, we're out of that function. Okay? It's similar to how you do a break in a loop, right? You can have a break, and you can have a whole bunch of things underneath the break. Nothing's going to happen as soon as you hit the break. You're out of the loop. Same thing with the return. Okay? So I'm gonna. All right. So this here showed 0, 0, 0 because changing the list parameter changes the list argument. Right? That's the only time you can change the argument with the parameter. Okay. Any questions about any of this stuff? Okay, let me tell you one more thing, and that is going back to that thing that Marissa noticed with this is-pause right here. Let's go in there. So remember that is-pause was doing these 3 lines right here. The 10 is positive, true, 10 is positive, true, 10 is positive. Right? That is right, these lines. So this one, and this one. Right? But what is it going to do if I give it a print is pause 0? Right? I didn't tell it what to do for a 0. Returns is pause 0. What's going to happen if I do this? Right? Because remember, if it's greater than 0, it returns true. If it's less than 0, it returns false. What would it do if I call it like this? Well, let's find out. Run it again. None. So whenever you see this return none or whatever, it's because you didn't tell it what to return. So it's supposed to return something. You're calling it as it should return something, but what you're giving it is not, it's not going to make it return anything. So the no default return case, I'm going to say the default return case is just going to be, let's say, false or whatever. Return false. Okay, and I've seen people doing this kind of stuff like return. That's pointless, right? If you just have a return, that's like return none. Okay, so tell it what to return. So this is going to be, let's say, a false. Is a 0 positive or negative, Marissa? What? Is 0 positive or negative?
0 is not negative, so I would say positive.
So if I put a 0 returning true, you telling me?
I would say true.
All right, let's go with true. There you go. All right. And if I don't tell it what to return, let me take this out, Control X. You're going to see that return none business again. Okay? So make sure you give it a default return. Okay? And by the way, I could simplify this whole thing here. So instead of doing this, let me just do this. Yeah, whatever. So let's do this. I'm going to get this whole thing here. Yeah, I'll copy it. Copy this. Throw that in there. So it's pos 2. So what I'm going to do is I'm going to simplify these lines of code here. And then this is something, again, that if you have a fancier IDE like PyCharm will tell you, oh, you can simplify this block of code, right? This is how you simplify it. You just say return num greater than 0. And that's it, right? So this, remember, this is either true or false. So if this is true, you return true, otherwise you return false, and it pretty much does all that stuff, right? And you have a default return. Okay? So try it again. Maybe I should throw it in there somewhere. Let's do print the number -9 is positive. Okay? And then is pos 2 and -9. And keep your fingers crossed. Alright, there you go. The number -9 is positive false. Right? Any questions? Okay, so that pretty much covers everything I wanted to tell you about functions, variable scopes, returning values, arguments, parameters, definitions. Those are the basic terms. Let me see. Yeah, and I'll tell you about recursion on Thursday. Well, actually, what the hell? I'll tell you about recursion today. We have enough time, huh? We can do the whole thing in one shot. So let me tell you about recursion. Okay. So the last thing for this week, so that way you can get to just do your work on Thursday. Okay, last thing that I want to show you is recursion. Right? And recursion, in my opinion, is one of the most confusing things in programming. Okay? And I'll show you why. So let's say I have alright, let's say I'm going to call a function, I'm going to make it, the name is going to be recurse, it's going to take a number, right? And before I even write it, let's just do this, right? So first, quick review of loops, right? Loops review, right? And the review is this. Let's say if we have for I in range from 0 to 3, steps of 1, and I do print for I equals I, right? What is it going to show me? It's going to show me 0, 1, 2, right? That was one way to do it. Another way to do it is you say I is equal to 0 while I, well, let's do this. Yeah, I is less than 3. And then you do this here in it. This is going to be a while. And I'm just going to say I plus equals 1, right? That's the same thing as the thing on top. All right, I'm going to run it so you can see it. All right, so we know this already. Now, the next thing is I'm going to do this using a function, no loop. Okay? So, and recursion is a function calling itself repeatedly until a certain condition is met. Okay, so I'm going for 0, 1, 2, right? So what I'm going to do is I'm going to call my function. I'm going to go in there, I'm going to say recurse. I'm going to start this thing at 0. Okay, and I'm going to tell it, all right, print the num. So I'm going to throw recurse num equals recurse. Whoops, not recurse, but num. Okay. So what's going to happen the first time I send? I call this, right? If I just do it the way it is right now, what is it going to do? We're going to send the number 0 into the function, right? And it's going to show you recurse num equals 0. Yes? Okay. Now, what I'm going to do is, I'm going to tell it, all right, if my num is less than 3, call yourself with num plus 1. Right? So what is it going to do? It's going to go in there, and so initially this thing is equal to 0, right? Shows recurse num is equal to 0. Is 0 less than 3? Yeah, it is. Call yourself with 0 plus 1. It goes back. Now it's a 1. It's going to show you recurse num is equal to 1. Is 1 less than 3? Yeah. Call yourself now with 1 plus 1, which is a 2. Shows the 2. Is 2 less than 3? So maybe I should stop this at less than 2. Right? So as soon as we get to the 2, it shows 2. Is 2 less than 2? No. Stop. Okay? So if I run it this way, hopefully, same thing. Okay? Pretty easy, right? All right. Since you're nodding, how is this going to change if I moved here, this from there? And those of you who already know the answer, shush. What is, it used to be this, right? 0, 1, 2. Recurse num is equal to 0, recurse num is equal to 1, recurse num is equal to 2. What is it going to look like now? All I did is I moved the print from here to there. Print's the last one. Okay, any other guesses? What I like to do with recursion is I'll go and I'll ask, like, for everybody who doesn't know this, I'll just ask for their guess, and usually nobody gets it right. So give me another one. You already had a guess. Somebody else give me a guess. First one, last one. Okay, any other guesses? Well, let me just run it. Let's just run it and have a look at it. It shows it in reverse. Why is that? I guess, I wish I could draw this stuff actually. Where can I put it?
Have a board.
Huh? I have a board, but I'm trying to record this thing for the online people. So I'll throw this. Let's do Excel. All right. See if I can copy paste this picture in Excel. Yeah, it's not really going to work, but whatever. Okay, so I'm sending over. Go back to this and get this here. I hope I can draw on this thing. Okay, so initially what I'm doing is I'm sending the number, this is a 0, right? 0 goes into the alignment there, right? So initially I'm sending the number 0, right? The next thing that I'm doing is, do I have any shapes on this thing? Shapes. There you go. So as soon as I'm sending the number 0. Is 0 less than 2? Yes, it is. So call yourself with 0 plus 1. So then from here, we go and we do another call. But this time, what I'm doing is I'm sending the number 1. Okay? So far, so good? So then it goes and it repeats basically the same thing. So let me copy this picture. I'm going to throw it right here somewhere. Alright, so then it's 1. Is 1 less than 2? Yes, it is. Call yourself with 1 plus 1. So then it goes and we're calling it one more time. So now the number here is 2, right? And since it's 2, 2 is not less than 2, right? Is 2 less than 2? No. So we're not going to do whatever's inside the if. What's left is just the print. So at that point, I'm showing you recurse num is equal to 2. As soon as I get to the end of this here, now I go back. Let's try one of these. I go from here back to where I was called, right there. Let's call it there, right? So I call another instance of this function. I do whatever's inside the function. When the function is done, right, I return back to where I was called, which was right after this, right? I'm gonna end right after where I was called, and then at that point I'm going to show you recurse num is equal to 1, because this function was called with the number 1, right? And then at the end of that one, right, when this function is done, then I go and I return back to where this was called, and then I show you the last one, which is recurse is equal to num equals, what's num for this function? It's 0, and that's why it shows you 2, 1, 0. Okay? And that's why recursion is confusing. Is it more efficient than loops? No, it's actually slower. If you have a whole bunch of recursive calls, if you exceed more than 60 or something like that, the program will crash. So why would we want to reuse recursion if it's slower and crashes things? Because sometimes it simplifies conceptually how you can solve problems, right? So when you get to data structures, you're going to see there's different ways to sort things. Well, which one was the one that uses recursion?
We haven't used any.
Do we have recursion in recursion? Not yet?
They've all been like nested loops.
I didn't do
We've
the...
done bubble sort, select sort, and insertion. We've only done 3.
There's other sorts. I can't remember what it's called. Hold on. Let's do this.
It's that picture.
Yeah, different sorting algorithms. Where's that picture?
It's the one where it just breaks it up a bunch of times, right?
This stuff here. I think it's the merge. No, it's not the merge sort. Insertion, selection, bubble.
Those are the ones we did.
I think it's merge sort. So let's Google merge sort. So with the merge sort, you start with a list of things and you split it in halves, right? And then you further split it in halves until there's no more halves left. And then you start reassembling things in the correct order. So if you were to try to do something like this using a for loop or a while loop, it's really complicated. It's much more difficult to solve this. But if you use recursion, you're basically telling it, okay, if the list is a length of more than 2, keep calling yourself with half the list, keep splitting the list. And then when the list is done splitting itself, then you just start combining the things in the correct order. And this is a lot more efficient algorithm. The other sorting algorithms, even though they seem easier and conceptually easier to write, this is a lot more efficient. Okay? So anyway, there's certain problems in mathematics that just become easier to solve if you use recursion, and that's why I'm telling you about recursion. Okay? Any questions? All right. So that's what's happening here. All right. That's your recursion business. Now I have drawn this in Excel too. Okay. So that's pretty much all I want to tell you. Do you want me to go through the assignments and give you clues on things? Anyone want some hints? Okay, I see a nod, so let's go through the assignments. And, all right, so you have function 27. Right, I pretty much give you all the clues that you need in the assignment itself. Right, write a function named is divisible that takes 2 integers n and m and returns true if n is evenly divisible by m and false otherwise. Right, I show you how to call these. right? So there's a print in there with some text, and then there's your function call, right? And then all the function is supposed to do is it's supposed to check to see if one number is evenly divisible by the other. And here's your hint. A number m is evenly divisible by a number n if m modulus n equals 0. So you just have a function with one if in there, and that's it. Okay? So I guess you could say that, which one was that? This is P27 hints. Where is this? So this kind of a business here. All right, this is hint P27, right? Similar to this one. Okay, and now let's go to the next one. Mult add, and these are, really easy things, right? As long as you understand what's a parameter, what does it mean to return a value, it all comes, it's pretty straightforward. Okay, so you're going to write a function called mult add that takes 3 floats, a, b, and c as parameters, and then returns a times b plus c. Baby stuff, right? All you have to do is make sure you write a main function which starts the program. It calls the mult add function giving it this, right? So let's just go back to the main. Where's my main? Where did I have a main? Forgot where my main is. Main is right here, right? So this is your hint for P28. Hint P28, right? So all you're going to do is, in this case, we're calling a function that adds a couple of things. But keep in mind that this function here is printing values you're supposed to return. So let's just make another one. I'm going to say here df return v is equal to a and b, right? And I'm going to return a plus b, okay? And then I'm going to call my function in here, so I have to show it too. So let's say return val is equal to return v. Let's say 10, 20, or let's do 5, 6. Okay, and then I can do something like print return v 5, 6 returns and return val. Okay, so that's your hint for P28. 29 is triangle function. All right, a little more text in there. So what is the business with this? You're given 3 sticks. You may or may not be able to arrange them in a triangle. For example, if one of the sticks is 12 inches long and the other 2 are 1 inch long, you will not be able to get the short sticks to meet in the middle. And the test is this. Basically, if any of the 3 lengths of a triangle or these sticks is greater than the sum of the other 2, then you cannot form a triangle. Does that make sense? Any questions? We're good? Okay, so you just go in there and do a couple of ifs for the 29. Okay, so let's say I'm going to put that in. So this is your return hint for P27 and 29, right? Both of them. And then the next one that I'm going to do, I learn. Courses 42, week 5. All right, 29. Then you have one that's absolute val. Right, write and test the function apps num, which returns the absolute value of a. So of number. So if number is less than 0, multiply by -1, and return a thing. Yeah. So that's that. 31. Check to see if a number is even. How do we do that? Do you remember how to check to something if something's odd or even? Hmm? So this is hint P29 is if you have, let's say if num modulus 2 is equal to 0, print num is even. Okay? So that's your hint. You're going to have to put that inside of a function, and you're not going to print, you're going to return a value. Okay, so make sure that if it says return a value, you're returning a value. If it says show a value, you do a print. Okay? Because that's going to be, that's important stuff. So that's that. 32, recurse. I showed you how to work recursion. Write a function, recurse num, which calls itself until num is equal to 0 and shows num every time it calls itself. Right? I'm not going to have you do the 99 beers of, bottles of beer on the wall, which I usually do, unless you ask me to. Okay? So that's all you got to do. Okay? If you take C++ with me, we're going to do the beers. Okay. We didn't do that? You sure?
I'm positive. I would have remembered that.
All right. If you take this class with me in the regular semester, we're going to do the beers. But it's basically the song written recursively.
I understand.
Yeah, all right, good. Okay, so the next thing is coding bat. So now that we know about functions, let me tell you about coding bat. Coding bat is a neat little place where you can practice Python and Java. So let's have a look at how it looks, what it's supposed to do. So let me zoom in a little. There we go. Okay, so basically the way it works is they're going to give you a problem, right? So given a string and a non-negative int n, return a larger string that is n copies of the original string. So what I do, so this is what the function call is, and this is what the function is supposed to return, right? So this is a string, and you're going to return 2 copies of the string. This is the string, 3 copies of the string. This is the string, 1 copy of the string. So I just make a new string. I'm going to show you this because there's a solution if you want to click it. So basically it goes something like this. Let's say new string is equal to blank 1. And I'm going to make a loop, just the basic things we've learned, for I in range from 0 to n, steps of 1, right? And then we're going to go in there, I'm going to say new s plus equals this string. Okay, so this string starts as blank, and we're going to add as many copies of this string, which is this argument right here, right, into the new string. And then when this whole thing is done, you return new s. And when you hit the go button, and if you can see the whole thing, you're going to see that there's all the different tests are right here. If you get it all green, just take a picture, right? Take a picture of this whole thing, right? Take a picture of this, put it inside of a Word file or something, or you can put all the separate pictures in a zip file, but Word file makes it easier, right? Put them in a Word file and then submit it. Okay, so for this assignment, that's all you got to do. Just take pictures showing me the code on the left and the checked out with everything on the right, and that's it. Okay? Don't do anything, don't do print, right? You cannot use print inside of coding bat. If I do print hi, don't print computer and return a result value, right? Also, you're not going to call the function. Okay? The web page itself will call the function for you. Okay? It kind of automates the testing for me. Okay? So yeah, the first couple of assignments, the extra n, the make tags, the combo string, the count codes, those are relatively straightforward. Count code gets a little bit more complicated, and the XYZ there is the most complicated of all the coding bats. Okay, so use only things that you have learned in this class. okay? I know you're gonna feel the urge to go and Google a solution, but if you're not solving this thing using what you have learned in this class, I'm gonna take some points off, or lots of points off, okay? Unless your solution is using enough of what you have learned, okay? But basically, if there's like a need, and I tell you, in a lot of these coding mats, not in the beginning, but later on I'll tell you, you can't use sum, you can't use count, you can't use a lot of these built-in functions from Python. You could use them if you write them yourself, okay? So that's that. That's the coding mat, 33, and that's the last for this week. Any questions? All right, if you have them, let me know, send me an email so that I can help you out. We're at July 18th. There's only 10 more days left. All right, so make sure you turn in your stuff before the 28th, because I don't want to grade anything after that. Okay? Alrighty, so I'll unplug this so you can get started.